Our next speaker is Dr. Rafiya Javed, a data scientist at Mailchimp. Dr. Javed is a data scientist, or before becoming a data scientist, she has been a physician, founder, and radio host. Rafiya co-hosts the Data Science Journal Club podcast and is passionate about sharing new ideas. Please give a round of applause for Dr. Javed.
The title of my talk today is Collaborative Learning, Lessons Learned in Creating a Data Science Podcast. But before I start, let me tell you a little bit about myself. So before I was a data scientist, I was a medical doctor by training, realized I really didn't like clinical work, and so I left to get a master's in computer science, and I became a data scientist. My podcast co-host and my husband is a physicist by training, and he also transitioned to become a data scientist. So we're extreme evidence of sort of the diversity of education or background you might find in the population of data scientists as a whole. So today my talk is going to follow this format. So I'm going to give you a little bit of background about why I'm giving this talk and why it's interesting. I'm going to define collaborative learning, and then I'm going to give you some suggestions about how you can do a better job of collaborative learning. So a few months ago, there's a really bright light, sorry. A few months ago, we decided to start recording a data science podcast. And one of the reasons we did so was that we realized our jobs required a lot of continued learning. And there's not always a clear avenue for doing so after you leave academia. So over the summer, we thought, okay, well, podcasts are the new thing. Let's start recording a podcast about new topics we're learning and learn them better by teaching them to each other and to an imaginary audience. And let me clarify, this podcast is actually a tiny pet project. So we have about 7 episodes so far and 30 listeners on Spotify. But while I was writing content for this, I ended up listening to a really wide variety of other content out there. And it turns out there's over 185 data science podcasts on Spotify alone. It's an extremely popular educational format, right? We all have really long commutes. We're really tired of staring at computer screens, and this is a really nice format to just passively listen and learn. And I countered this using keywords like data science, artificial intelligence, machine learning, but I'm sure if you did a count of your own across other platforms, there's even more. And so I thought a lot about what made the good ones so compelling, right? Why are the good ones so worth listening, and why are people so interested by these? And it was a variety of factors, but sort of the common ground amongst all the more compelling data science podcasts is that the people doing them are surprisingly good at having robust, interesting, technical conversations between 2 or more people with different perspectives on data science. And so listening to those, I thought, okay, well, is there something from this that I can bring back to Mailchimp? Is there a way I can improve the collaborative discussions I engage in, probably on a daily basis, with the team around me? So after our first episode was about a reinforcement learning topic, we sort of hit our first challenge, right? So when you're creating content, you have to have a target audience in mind. And our target audience, we thought, was early to mid-career data scientists. But it turns out we had a lot of unanswered questions about them. So for instance, can you assume that all of the early to mid-career data scientists know what a Markov decision process is? Or when you explain the concept of a variational autoencoder, do you do so from the perspective of a statistician, or do you explain it from the perspective of someone that knows a lot about neural networks? So we realized this was actually a hard problem. We hadn't narrowed down the people we were talking to as much as we thought. So this is a study done by 365 Data Science on 365datascience.com, and it's basically studying the academic background of data scientists in the industry. And as you can see, only 13% of people with this job title actually have a degree titled data science or analytics. 11% of them come from a natural sciences background, like physics, chemistry, biology. 19% are from an economics or social sciences background. 19% are from a statistics or math background. And then there's computer scientists and engineers. So it's extremely probable that if you're not on a data science team, you're going to see representation from a variety of different fields. And the underlying dream here, the dream is that when you have these teams of these really diverse and talented people, that you're going to get really novel and creative output from them, right? If you mix all these contexts together in one room, wonderful things will happen. But it's actually difficult to leverage educational diversity or benefit from it as an individual contributor unless it's intentionally done. So there's a couple of default responses that we usually have that don't work in this setting, right? So in academia, if you're talking to an audience from outside of your field, you'll want to give a high-level explanation of what you're doing and why it's cool. And you'll want to avoid technical details, right? But we're technical teams doing technical work together. We don't want to leave out details. We want to evaluate and have our ideas evaluated at that level. So if you solve this problem successfully, right? If you get people from these different backgrounds actually speaking to each other on a meaningful level, that's sort of the definition of collaborative learning. And so collaborative learning is essentially a term that refers to leveraging intellectual diversity successfully. And sort of the most important elements are capitalizing on one another's resources and skills, evaluating one another's ideas, and building a shared understanding that serves as a reference point. And that means you've gone on a shared mental journey that you can refer to and build off of later on, right? I don't have to explain to someone what a Gaussian is every time I want to talk about a normal distribution. And it's more effective. Collaborative learning has better outcomes, right? It's more effective. One of the studies I linked on the previous slide is about school children studying math in the 90s. And the evidence showed overwhelmingly that those with some sort of collaborative learning as part of their curriculum had a much stronger skill set, right? And we know this intuitively. We have a sense that when we work on teams where we have interesting and meaningful conversations with our coworkers, we're growing a lot faster, and we tend to seek out environments like that. But we never intentionally try to be good at collaborative learning, right? It's something that we stumble upon if we're lucky. But if it's so beneficial, right, if there's so much evidence that it's beneficial, then maybe we should try. Maybe we should try to create environments that foster this. At Mailchimp, we have a very collaborative culture, so we spend a lot of time, we're really encouraged to speak with each other and learn from each other's skill sets. So after, creating this content and looking at all of the other content out there, I thought a lot about how I could use lessons from there to improve collaborative learning skills. So for the remainder of this talk, I'm going to tell you a little bit about those lessons. So the first lesson is to learn from the rules of improvisation. So what improv musicians and improvising comedians do really well is maintain constructive dynamics, right? So for collaborative learning, that means you want to maintain a dynamic that always moves the discussion forward instead of halting it. And to put that simply, that means there are no mistakes, only opportunities. So what are the takeaways for a collaborative learning setting? First of all, the goal is not to have mastered a subject or devoted yourself to it in its entirety, right? The only goal is to have built a shared understanding. And if you can do that, then you've made progress and you've gained something. And if you see the goal that way, it also becomes a lot less intimidating to participate. And the second takeaway is that vulnerability is good. So unplanned interactions are usually the ones where we gain the most new knowledge. And a really good example is right here. I'm giving this talk. I've written it all in advance, and I'm giving it to you right now. And it's very unlikely that you'll cause me to critically examine the thoughts that I'm sharing right now, right? And so those interactions where we go in with vulnerability and a lack of planning are likely the ones where we'll learn the most. Part of having these vulnerable interactions is also to appreciate that they're going to be different with every person. And so that takes us to the next lesson, which is to appreciate that there are different languages to describe the same ideas. Because of the diversity of backgrounds in data science, this is sort of like step 0 of having a good learning dynamic. So an example, a notational difference that was given to me is in machine learning, alpha is a really common Greek letter, and we nearly always use it to mean the learning rate of a model, right? That's always what alpha means, almost always. And if you talk to someone from an economics or econometrics background, they see alpha as synonymous with the y-intercept of an investment's return as a function of the market. And if you talk to someone from a physics or math background, they might be really surprised to learn that you're using alpha to signify the same thing every single time, right? And so the idea here is that it's a very useful skill to be prepared for the fact that people are going to use these field-specific terms and be prepared to translate between them. And that sounds really obvious, but it's difficult because we all have languages that we prefer and that seem more intuitive to us. But having acceptance and preparation for that can go a really long way towards being a better teacher and a better student. So a few slides ago, I said that a part of improv is to take mistakes and turn those into opportunities, right? But how do you actually do that? That's incredibly hard to do. It's hard to do in music, it's hard to do in comedy, and it's hard to do when you're learning. So one way you can do that is to communicate in layers from technical, like implementation details, to conceptual, so at the very high level. And if you communicate and understand ideas in a way that sort of interweaves these narratives, it becomes a lot easier to build that shared understanding, because people usually approach a new idea from somewhere within the depth of these layers, right? So for one, it becomes a lot easier as the recipient, like as the learner of an idea. One of my favorite episodes that we did is called The Physics of Neural Networks. And it's actually about how you can use ideas from statistical mechanics to better understand why deep learning has the unexpected regularization properties that it has, right? And so I was really excited for this episode. It was going to draw a really cool analogy between neural networks and like something that we can see and have more physical intuition about, right? And David, because of his background in soft matter physics, was explaining to me, hey, here's this thing that happens in the energy landscape of crystals. And that was completely outside of my domain knowledge. I didn't understand why we expect crystals or any materials to sort of behave the way they do. And so my strategy there, sort of because of this layers strategy, was to, okay, well, I understand the weight matrices of neural networks, right? I can ask questions at this technical level and build my understanding from there until I can tie it back to this cool high-level analogy with a completely different field that I don't know about. And that worked really well. And I think that the benefit of seeing things this way is that you can really contextualize where your understanding is blocked and find a way to move past that obstacle until you can reconnect with the person that you're sharing ideas with. And it also has a lot of benefits as the teacher, right? When you're explaining a concept, you always want to feel like you've imparted some kind of knowledge. And so the first benefit is that you've given people this opportunity to reconnect by traveling up to a more conceptual layer, right? Even if they're not following the technical details of what you've said, they may still have built this like high-level, solid understanding that they can build off of later on. And the other thing to keep in mind is that the technical details are still important. They provide anchors for the high-level idea. When I was writing an episode about GANs, I talked to one of my friends who's an aerospace engineer who does a lot of self-learning about machine learning. So I reached out to him and I asked, well, you listen to a lot of podcasts, right? What do you like and not like out there? And he sent me this 20-minute long video about a genetic algorithm. And it was a beautiful video. It's like this robot learning how to walk better over time. And he said that after he watched it, he could tell from the title, like genetic algorithm and the analogy to evolution, what it does. And he said that at the end of the video, he felt that they had called some API or some loss function with some inputs and outputs, and they hadn't really specified what those were. And he felt like he hadn't learned anything. And so the idea here is that when you're talking to other technical people, they're going to want technical details, right? And those can also serve as mnemonics to remind you of a concept even after the idea starts to fade away. The next lesson I have is to ask helpful questions. So collaborative learning is all about taking asymmetric roles, right? Sometimes you're the teacher and sometimes you're the student, and a lot of times you're both the student. So when you're the student, you're playing just as important of a role, contributing to shared understanding by the questions you choose to ask. And what do I mean by helpful questions? So obviously any question is good. All questions are a sign of engagement, right? But some questions are more helpful than others. And a good goal to have in mind is to try to improve your own understanding and the understanding of others. So helpful questions are often those that color and fill in the outline around an idea that's being illustrated, right? So one way you can do this is to map a new concept in relation to older and more familiar ideas. And this is really helpful for everyone because everyone around you that's also learning, because you're tying a new idea back to older and more familiar ones and sort of filling in this like geographic map of ideas. So for instance, if you're learning about a new type of reinforcement algorithm, maybe you want to compare how it's different to an older one like Q-learning. Another way you can do this is to try to elaborate the conceptual narrative, right? Ask for technical details to elaborate a conceptual narrative, or vice versa. You could try to rephrase a bunch of technical details at a high level and assess whether that's correct. So sort of traversing those layers can also be a really good way to add additional context to a new idea. And if you guys have ever listened to the Lex Friedman Artificial Intelligence podcast, he's really good at doing both of these, actually. His interviews are all at a really high level with these really great minds in AI. And he's really good at asking these high-level questions that sort of compare and contrast a new idea in relation to older ones, not just in machine learning, but in neuroscience or philosophy. And that makes the conversations really satisfying because you always come away feeling that you've filled in part of your mental map of the world. And the final lesson here is to practice. So the funny thing about creating podcasts is that it's a very performative form of learning, right? So you spend a lot of time editing your own audio and listening to yourself discuss a topic and hearing yourself improve over time, right? So this is something you can actually get better at over time. It doesn't have to be a skill that some people are born with naturally. It can also be attained. And so I really recommend integrating some form of collaborative learning into your individual learning strategy. And if you can do it as a team, right? The advantage of doing it as a team is that you're going to get a feel for how the people around you learn. And so therefore, you're going to get increasing returns over time. Yeah, so that's all for me. And this is a link to my podcast. And thank you for listening.